For this video, I'll be walking through an example problem on graphing higher order polynomials. In this, we'll be finding a cubic equation and then using Desmos to colour in regions between functions. So a spaceship moves on the border of a region of space dust. The trajectory of the spaceship is given by a cubic equation having the x-intercepts as 1, 2 and 3, while the y-intercept of the trajectory is 12. First, we want to write the possible equation of the spaceship's trajectory. Then we're going to colour the region of space dust below the trajectory of the spaceship that lies between the x values of 1 and 3. From the problem, we're given information that the spaceship trajectory cuts through the x-axis at x equals 1, x equals 2 and x equals 3. So we can write these values into our cubic intercept form. This would be y equals x take 1, x take 2, x take 3. And we can see that gives us a trajectory that passes through the points on the x-axis. However, the problem said the trajectory of the spaceship also cuts the y-axis at 12, which we don't have at the moment, as instead it's cutting through at -6. We get this value because at the y-axis, x is always equal to 0. So if we substitute into the equation x as 0, we should get our y-intercept value. So in this case it becomes y equals -1 times -2 times -3, which gives us y equals -6. So now we might wonder how we could change our y-intercept without changing our x-intercepts. We can do this by adding a number to our equation, which will affect the gradient of our function. So if we were to rewrite our function, but this time adding a variable in front, so if we copy that, if we add a variable such as a, we will then be able to add a slider which we can adjust. From this we can see that by decreasing our value of a, this is how we get our y-intercept to increase. When we make our value for a equal to -1, we notice that our function is now a reflection of our original and is now passing the y-axis at 6. Writing this out again for when x equals 0, we can show this as y equals our a value, which is -1, multiplied by our x, which is 0 take 1, 0 take 2, 0 take 3, which now gives us y equals 6. Now we want to make our y-intercept equal to 12, which is twice the value of 6. So to do that, we can double our value for a and make it -2. Now if we were to zoom out, we can check that now our y-intercept is at 12 and our x-intercepts are kept at 1, 2 and 3. Now this leaves us with the correct function for our spaceship trajectory. The second part of our problem asks us to colour in the space below the trajectory between x is 1 and x is 3. If we change our function so that y is now less than or equal to our right hand side, we can see this highlights the whole region below our function. Now we can begin to restrict our domain so that only the region between x is 1 and x is 3 is shown. We can do this by writing the condition that 1 is less than or equal to x which is less than or equal to 3. Now, the last part of our problem asks us to draw y equals negative x squared, and to instead highlight only this region here that lies between our two functions. Similarly, the area above our y equals negative x squared can be highlighted by changing our equation so it's now y is greater than or equal to negative x squared. And again, we want to restrict the domain so only the area between x is equal to 1 and x is equal to 3 is highlighted. We can do this simply by copying this and pasting it into our new function there. Now, our final step is to combine our two functions so that only this space is highlighted. So if we look at our first relation, we can see that y is less than our cubic function, but here y is greater than our negative x squared function. This can be rewritten instead as negative x squared for when x is between 1 and 3 is less than or equal to y, which is the same function we had before. And now we can combine our two functions as part of the same equation by copying this function and adding it onto this one. This is now saying that only the points are shown for when y is greater than our parabolic function, but y is less than our cubic function, so long as x lies between 1 and 3.